1 to 4 from here, because this is also this, yes? So the ratio of moles of C to moles of mixture is 1 to quarter. Now, he wants to know how many molecules of C per 400 molecules of mixture. I have 4 molecules of mixture, I don't have 400. So what am I going to do? Multiply by 100. So I make it 400. But I don't want to change the ratio, so you multiply also this one by 100, and there you go. 100 C per 400 molecules of mixture. There you go. Every step when we do it not by accident. We do it by a logical sequence. Did you observe that? Learn to think. Then you don't have to do many problems. All this is insanity in education. Online problems here, online problems there. Homework here, homework there. Do as many as you can. No. This drives the students crazy. That's not the proper way of doing it. We need to change it. If you do a few problems correctly, by reasoning, to understand why you're doing every step, eventually you will have to solve only 1 or 2 problems for every concept, whatever, not dozens of problems, and going crazy like this. I don't have time, I don't have time. When you learn to think, it will be so much easier. But to have the stamina to learn to think, you must love what you are doing. That's why your teacher showed you these videos. The secret is embedded in these speeches that you heard. If you believe these speeches, the spirit of these speeches, you are on your way. Nothing can stop you. Like Steve Jobs. Nothing will be able to stop you. You will be very successful. No matter what happens, there are jobs or not, no, it doesn't matter. You will always be successful. He was fired. He reached the peak of his success, even after he was fired. Because he said, I simply did what? Loved what I was doing. And all these myths that you hear from so many voices around you, go because there are jobs. Go because there's this higher salary. Go there for any other reason. It is based on fear. Everything that's based on fear is destined to fail, sooner or later, and to bring great disaster and sorrow. Everything, decisions that you're making should be based on what? On love. If you follow this, you will never be sorry. All the time if you follow it. We many times will fail. Get up. Don't think about your fall. Get up. Get ready to fall again. Because you will fall again. Get up again. That's the way you become strong. Don't look back and feel guilty about it. Because everybody does that. Falls up, falls up. There are cultures that tell us failure is a shame. That's the biggest lie that you can ever hear. We should accept failure and success equivalent, the same way. They are both lead us to success. As much as the success, the failure leads us to success. Equally. No less, no more, equally. When we accept this, we will be truly successful. So, let's do, there is a couple of problems that we cannot do today because we have not covered this material for the Monday and Friday, Wednesday, right? That's just 1 or 2 questions only. And anyway, you'll do well because we'll cover them next, okay? So let's do this problem here. Right. Okay? That's just really to make sure that you put the units in the right way. It's not really like a special problem here. You just have to make sure that you put the numbers correctly. the equation is given to you. The only thing you have to really plug the numbers. It's not a big deal, right? You want to do it, or you want to observe? You're lazy to do it? Huh? Just be careful with the units, huh? Speed of radiation, electromagnetic radiation, therefore light, which is a form of radiation, right? Is equal to 3.0 times 10 to the 8 meters per second, right? That's a constant defined in the last page of the exam. And that speed is equal to frequency times wavelength, right? How much did you find? Which is the answer? Anybody found the answer? A, B, C, D, E. What is it? Anybody did it? Huh? Nobody did it yet? Numbers, huh? Okay, so the equation tells us the frequency is equal to this, and we just have to put the numbers there, huh? 3.2881 times 10 to the 15. And then you have 1/4 minus 1 divided by 1. 9. 5. Okay. And therefore the frequency comes out to be 4.57 times 10 to the 14 second minus 1, or hertz, doesn't matter. The speed of light, or radiation in general, is of this equation. So the wavelength is going to be speed divided by frequency. You make sure that you put the correct units. Meters, and meters go away, second minus goes away, you have nanometers. Lambda is equal to 656 nanometers. There are two schoolmates of yours up there, for your own sake, selflessly, they are taping this session. This session, being videotaped, will be able to be seen in the future, other years, by other students. Hopefully, they will benefit from the messages that you saw today. And of course, the ones that they didn't come today, and they will probably, some of them will look at tonight, they will still see these things. But how much help are they going to get? Unless they change their attitude to be loving with what they're doing and to be persistent and serious about it, it doesn't matter how many times you will see the movie, the video, or the messages, not much will happen. Because it's the mindset, the attitude. It's not how many times I will see the movie and the message from Steve Jobs. It's about being persistent, with no doubt. There's that statement that the teacher put in the front of the document camera at the very beginning. You remember that? Did you write it down? This statement? How many people wrote down that statement? How many people? Raise your hands. All the way up your hands, the statement that the teacher put in the document camera. How many people put it down? Copied it down. Let me see your hands. Some people did it. About a dozen people did it. How about the rest? Why you didn't write it down? Whenever you see something which is beautiful and someone is giving to you because he dreams of you all the time to be successful, why would you not put it down and put it in front of your eyes, in your office, in your wall, and look at it every morning? And try to understand what that statement says. Have faith. There are people that care for you. Not just one. Many more than one. Have faith. There are people that care for you, truly care for you. More than one. Don't lose faith because many people don't care. There is a lot of other people that do care. Focus on the positive, always. Focus on the people that care. Become one of them. So this wasn't an easy problem, right? Let's see a couple more. You want to balance one? We have a choice. We can do one about, let's see, we can do this one to balance the dots, and we can do this one here. Which one do you want first? 17? Okay. So, let's see what this problem says. Again, we're going to put down what we know and what we do not know in symbols, numbers, and everything, right? So I'm reading the problem. There are so many grams of the monoprotic acid. Therefore, you know what? The mass. Give the symbol to it. Don't just look at it. Name it. Give the symbol. 18.2 grams of what? A monoprotic acid. What are you going to do now? That's very important. That's what I'm telling you. That the step that you are writing things down, and then you can say, I'm not going to look at the problem. Whatever I see there, it's enough for me to solve the problem. You have solved the problem 50% already. You understand? 50% of the problem is solved. 50%. When you hide it, and you know, and you just know what you wrote down. So that's why you need to write very carefully down, so you don't need to look at this anymore. So what it says, of a monoprotic acid, what I'm going to put here now. The form of the monoprotic acid. How does a monoprotic acid looks like? Monoprotic acid means it has one hydrogen which is ionizable. Yes? So one hydrogen is ionizable. And the rest, when it dissociates into water, will be the anion. Yes? Who cares what the anion is? We don't care. A. Anion A. But the form of the monoprotic acid will look like that, the general form, right? One hydrogen ionizable and the rest will be the anion. Okay, great. Now what's the next? We have a solution of this acid, which is 0.10 moles per liter. And we have how much volume of this acid? 5 liters. 5 liters. And what it's asking us is HA, the identity of it. These 3 lines means, what is it? The identity. Which is it? Is it nitric acid? What, do you know many monoprotic acids? Is it nitric acid, hydrochloric acid, hydrobromic, hydroiodic, acetic acid? All these are monoprotic, right? Which one is it? What do we need to find? If we find the mass of it, then we know what it is, correct? More or less. Hydrogen is 1. So really what we have to find out is what's the mass of that A. Maybe then we can think about, is it a chlorine, bromine, iodine, nitrate, acetate? What kind of an ion is that, right? We can probably find it. Probably will be an easy one. Yes? So really what we're looking for is what? The molar mass. How many grams per mole is this acid? How many grams per mole of this acid? We are looking for the molar mass. Yes? Okay. So have we finished everything we want to put down? Yes, we did. So if you look at this, you do not need to look at the problem anymore. Done. Only this is enough for you. You understand? Right? So now, we're going to start thinking this way. Again, teacher will not put things down without explaining to you why he does it. Learn how you think by imitating him. Or any other teacher you find out to think this way. You want to find the molar mass. How do you relate molar mass with some other things? Because you have to relate it to these things. So how do you relate molar mass with things like that here? Moles per liter, molarity is moles per liter. Oh, moles. Moles. I want molar mass and talks about moles. I want molar mass. Does that relate to the things that I know, to moles? How? How do they relate? You know, always that number of moles is equal to what? Mass in grams per molar mass in grams per mole. I want this. And the only thing I need to know is this and that. Do you agree with that? Okay. So molar mass that we need to find out is going to be equal to mass in grams divided by the number of moles. I already know that the mass is how many? 18.2 grams. So I will find out the molar mass of this. Then I can subtract 1 and find out how much A is, and that way I will probably know what the acid is. If I know the number of moles. Do you know the number of moles of the acid if you know the concentration of inlet volume? Of course you do. So the only thing you have to do is, you remember that MV is equal to number of moles if the volume is in liters. And therefore, what you will do is, you have 0.10 moles of HA per liter of solution, 1 liter of solution, and you have what volume? 5 liters of solution. All right, great. So the number of moles that you have is 0.50 moles of 8A. You're done. You put this number there, and molar mass, 18.2 times divided by 0.5 will give you the molar mass, 36.4 grams per mole. That's the molar mass of this. Or you can say in AMU, right? The same number, grams per mole, is also in what units? AMU, for 1 molecule, yes? So 1 molecule HA is equal to 36.4 AMU. 1 molecule of HA is 36.4 AMU. So many grams per mole. Yes? So what's the acid? Well, if this is 36.4 and hydrogen is 1, that means A minus, because H will be plus, right? It's an acid. A minus is how much? 35.4 AMU. So what kind of that anion is from the monoprotic acid I mentioned before, because there are not that many that you know, that will give you a mass of 35.4, 35.5. Look at the periodic table. We mentioned it. What is it? Chlorine. You see? There you go. So the acid is hydrochloric acid, right? And therefore, HCl is the acid. All right. We're doing good? Perfect. We have 10 minutes. We can finish the redox balancing. Yeah? Didn't we do good? I think we did perfect. All right, let's do the balancing of the redox. All right, great. So now look at this problem. The problem that the different problems you might see, they don't have to be molecules, they can be ions, right? You know that. This problem, to balance this equation, which is a redox reaction, right? You can actually balance it just like this, by inspection, right? And you should know how to do that, right? Does anybody wants me to do that by inspection? How many people want me to do by inspection? Lift your hands. Come on. You don't care about the opinions of others. Come on. So, you have, it's actually ethanol. So you burn ethanol. C2H6O2, yes? Correct me if I'm wrong. Is that the equation you have? Yes? Okay. So the way you balance it by inspection, huh? Oh. Okay. So the way we balance this by inspection is really easy. You start from the most complicated one. You assume this is 1 because you have to start from somewhere, right? So we start with one of this. How many carbons do you have? 2. How many hydrogens do you have? You don't have any here. 6. You have 2 here, so I'll put 3 here. This is finished. That means all options are balanced here. I mean, no balance counted. So how many do you have? 4 plus plus 3 makes 7. Yes? Therefore, I have to have 7 oxygens here. If you are 2 in a hurry, you say, I'm going to put 7.5, because times 2 will give me 7, you are made it wrong now. Because you forgot there is oxygens there. Okay? So, I'm not going to do that. I want 7. This is 7 oxygens. And I want 7 here. I already have 1 here. So here I need how many? 6. This should be 6. So how am I going to make it 6? Okay, that's it. Now, the problem does not tell you to do it by inspection. The problem specifically tells you I want you to do it by the half reaction method. So you have to do it that way, otherwise you don't get credit. And the equation could be with charges. This one doesn't have any charges, but really doesn't matter. Has charges or not, we said we can do it without knowing anything about oxidation reduction, right? And then you find the oxidation numbers and you can answer all these 12 questions that your program always has, because always give you that problem, right? Because I want you to be familiar with the concepts of oxidation reduction. There are too many words saying the same thing, and you're going to be very confused when you take biology later and other science classes. So that's why I give you those problems all the time, to become familiar with the terms. Reductant, oxidant, oxidizing agent, reducing agent, blah, 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 right? Okay, so let's do this now, balancing. By doing it with the half reaction method, don't get about oxidation reduction at all. And then we're going to answer the question, right? So, what do? First thing is we break the chemical equations to 2 half equations by following common sense. We're going to have 2 half equations. Each one of them will have a chemical species. When I add these chemical equations, these chemical species on the left will be the reactants, and the chemical species on the right will be the products, right? So I start from the left. I have C2H6O. That's one of the half equations. And then arrow. And then I'm going to put, it goes to what? I want to balance this equation. So I need carbons here. I'm not going to put water. I'm going to put CO2. Yes? Now, a lot of students come to my office and they cannot do very simple problems like this. And the reason is because they're a little bit sloppy. They do not follow correct directions. You remember, Peter told you, when you do this type of problems, because there's too much going on, you have to be very neat. So put the arrows below each other. Just a few days ago, somebody was in office hours and could not do it because she did not put the arrows on the top of each other. That was the only reason they could not do it. He got confused, could not do it. Okay? So teacher has experience, every teacher has experience. Listen to their advice. Even though it sounds kind of detailed, no, it's not detailed. So the arrows, first arrow. Okay? Now, the next one is oxygen. Give space here, see here or there, to be able to add things. And then, when I'm going to put here CO2, I don't want CO2 there. I already used it anywhere there. And I don't have carbon there. I'm going to put water. Okay, that's it. So let's balance now these 2 equations by mass and by charge. Yes? What do we do first? Somebody would say, we don't need to balance by charge. Yes, you do. Why? Because you balance first by? You balance the half equations first by mass, not by charge. And you will realize when you try to balance by mass, charges are going to come in. And then you are not out of the hoop. You will have to balance by charge too. Okay? So the first thing we do is what? By mass. We have 2 carbons. 2 carbons. We have, what do we do next? We do all the non-carbon halogen elements, and then we do hydrogen. Last is the hydrogen. So now I'm going to do what? The oxygen. How many do I have? 1. How many do I have? 4. So I will use what kind of chemical species to balance oxygen? Water molecules. Because each molecule of water has 1 oxygen atom, I'm going to need how many molecules of water? 4 here, 1 there, I need 4 here, I need 3 oxygens. Therefore, how many waters? 3 waters. Right? That's it. Now, I have to balance the hydrogen. Right? How many hydrogens do I have here? 6, 12. 12. Nothing here. So I need 12 hydrogens. What am I going to put? 12 hydrogen atoms, 6 H2. What am I going to put? Always H plus. So I need 12 hydrogens in this form. Yes? Okay. So now this is balanced by mass. But now you see I have charges now. I better balance by charge too. Because the original equation did not have charge, that means I'm out of the hook. I'm still in the hook. Hooked up. I gotta get out. I'm going to balance the charges. This is 0 charge, yes? 0. This is how much? 12 plus. So what I'm going to use is negative charges to balance the charges using electrons. By using electrons, I don't disturb the balance of mass because the electrons are so much tinier than the molecules. Almost practically 0 mass compared to the molecules and the atoms that I have there. So I can use electrons. How many? That's it. So the first one now is balanced by mass and by charge. You agree? Okay. So this is equation A. Now let's go to the second one. What do we have? Everything else except hydrogen and oxygen. We don't have. Then, last is hydrogen, then oxygens. So if you have oxygens, then how many oxygens do I have there? 2. How many do I need here? 2. Good. How many hydrogens do I have here? 4. So I need, in this form, 0 charge here, 4 plus there, what do I need? 4 electrons. To make it 0 charge here as there. That's equation B. Now, I have to have the same number of electrons. So I'm going to adjust the quantities here. The quantities I'm going to adjust. So many electrons that are produced, so many they are used. Yes? Conservation of charge is called. Conservation of the number of electrons. I have 12 there, I have 4 there. So what do I need to do? Multiply this one by 3. I need 3 moles of oxygen to give me 12 to... I need 3 moles of oxygen to... because 3 moles of oxygen require 12 moles of electrons, which are produced from there. Yes? 12 moles of electrons are produced there. Per mole of this, there is 12 moles of electrons, correct? Number of particles, 1 gives you 12. Number of particles is also a ratio of particles, also a ratio of moles. 1 mole of this gives you, or we can talk about particles, you don't want moles. 1 molecule gives you 12 electrons, yes? 12 electrons have to be used. If one oxygen molecule uses 4, then I need 3 of them to use the 12 that are produced from there, right? That's why we multiply by this. Okay. So the B will become what? 12 electrons. They're all, there. They're all there. Not there. Not there. You will make mistakes. Under each one. And another thing that almost all authors make this way is that they put physical states of the chemical species. Aqueous, solid, liquid, gas. You do not need it. When you balance redox equations, you do not need the physical states of the chemical species. You already have to worry about so many things. Imagine to try to put all these physical states in every equation. Why would you do that? There's no reason. So don't do it. You need the physical states only when you talk about energy of the reaction and some other cases. But in this case, you don't need the physical states. So just don't write them down. Okay? So now we have 3 times 12, 12 electrons plus 3 oxygens plus 12 H plus. Will give us 6 waters. When you do this, be careful, you multiply the coefficient by 3. That will give you equation of C. So now you ignore this, because we used it already. So what do we have now? You have A and C. If you add A and C, what you will get is that 12 electrons and 12 electrons go away, right? Or you can add the whole thing from the beginning and put everything there if you want. You can hide this or just erase it. No, well, be careful. I mean, this and that, right? So it will be this thing here, plus 3 waters, plus 3 oxygens, plus, you see 12H plus and 12 goes away, can you see that? So the hydrogens go away, the electrons go away. Really the only thing you have is 2CO2